If people didn't see the intro to this air dryer thingy, which was in the last video, I'm just going to repeat a little bit of that just as a reminder of what I was planning, and it may help just to bring you up to speed before we start the new clips. I'm going to try and make up an inline air dryer just to improve drying. It's using some silica gel. I've got a bulk load of it, and I got this 2-inch nipple, a couple of end caps, and the idea is, and I don't know whether it's going to work, it may not be very effective, but I'm going to give it a try. So we'll drill the end caps, and then on one of them we'll braze in a long half-inch, that's a 1/4-inch nipple, a long one, and then the other end will have a short one, so we've got two male ends for fitting. And this will cross drill, alternate, 90 degrees, lots of holes, probably 1/8, 3/16, and then I've got some screen. This is not in itself enough to stop the granules, but the plan is to use that plus I've got some stuff my wife dug out. It's a sort of canvas type of thing which won't give too much air resistance, so we'll have that in each end, and then we'll also wrap this, completely wrap this all the way with the fabric and screen, and then fill this with, I don't know, 3/4 full of granules. Hi there guys, the old man's back again. We're on to the this extremely experimental air dryer, which I don't expect to work all that well, but I think it'll probably help. I've got the two end caps now. I drilled them out and bored them, and this end, this has just got to be tapped in, ready to braze. It's just a little bit tight. We just tap that in and braze it. That's the that's going to be the output end, and then this one that's going to be for the input, which I'm working on. These have been descaled, ready for brazing. So what I've got here is the long input. I did some math actually, I'm just trying to think. The cross-sectional area of the nipple itself is about 0.3 square inches, and I'm putting in actually 5/16, I was going to use 1/8 or 3/16, I'm going to compromise, sorry, 5/32. So I've got 7 through holes already, and then I'm going to repeat that at the 50% intervals all the way along. That gives 28 holes, which I worked out to be about, I forget now, did the math, about 0.6. Something like 0.6, which sounds a lot. Hang on. I'm just looking at my figures. Yeah, 0.302 square inches for the nipple itself, and 28 holes, that worked out at 0.614 square inches, which seems an awful lot, but the point is, even if I got the math wrong, it exceeds the cross-sectional area of the tube itself. I didn't put any flats on here, so drilling is very awkward. The drill tends to start to wander if I'm not careful, so I tend to, although I'm going by nominal inch spacing, if the drill wanders slightly, I just adjust the table a thou or two. Now that needs corrected. So we'll advance another inch. Just looking, I've got a 1.5 I've got to show because I was referencing from that hole. It's going to be about somewhere about there, so I'm going to do a touch and see if it'll start very gently. Slight wander. Just keep adjusting the X by 2 or 3 thou each way until it's reasonably happy. I'm actually about 10 thou off, but I say this is very empirical. So, very empirical. Few thou either way on these isn't important. I'll get these others finished off and then we can think about doing some brazing. Might even use my powered rotary table, I'm not sure yet. Alright, there's the, it looks like an instrument, doesn't it? I ought to have had a play a tune on that. In fact, it's not 28 holes, it's 26 because we got 7 there and 6 there, but it still, in theory, exceeds the cross-sectional area of the nipple itself. Then we got an end cap to close it off, and then, as I said earlier, I think on the last video, this will be wrapped in fairly porous fabric and then finally screening around the outside. There's going to be a lot of resistance in it, I'm sure, but we'll see how it works. So that is ready for brazing, that end. And this end, it's tight, but there we are. Probably braze it around about there. And one thing I meant to mention earlier, do you know something that really ticks me off? And I guess it's a problem in summer particularly. When we get the humid weather and when I get hot, you know, you sweat, everything sweats and your hands get a bit damp. And I've noticed if I touch bright metal and don't clean it off, damn thing flash rusts in a hurry. So there are advantages and disadvantages to the time of year. Anyway, I think I'll set up and see if we can get this brazed. I'm just setting up to try and get this brazed, or the two of them brazed. I'm going to make a couple of 3 tacks. I'm trying to set my support up. I haven't used this table much for quite some time since I made it, but I should be able to manage there. I'm going to try it. And out of interest, I forget whether it was Jody on Welding Tips and Tricks or TIG.com. See if we can read this. It's called Easy TIG Weld. It's a special alloy which is basically for joining dissimilar materials, and it's also good on cast and rough iron. So I'm going to use that and see how we get on. Oh, by the way, do you ever get a pesky fly in the shop? And just as you're concentrating on doing something, it lands on your nose or your leg or your arm? I've got one in here. It's war, but I haven't caught it. Not yet. Excuse the fan running. I'm trying to decide on speed for the turntable. I think probably pretty slow. But the other thing is, I've got a foot pedal for the TIG, and I never was good at playing the drums, so I've got to try and work both. Anyway, before I do any tacks even, I think I'm going to preheat this piece, which is pretty heavy, get that up to a couple of 100 degrees possibly. Well, I didn't have the camera running. Probably didn't want to embarrass myself, but there was actually still some zinc. I dealt with the outside, but a certain amount of zinc inside. I didn't get much in the way of fumes, but there was definitely some. I could get the white powder, and that isn't very pretty. Trying to get a good take on that material, but I'm going to let it cool off and then we'll try the other one. Well guys, change of plan. This is an absolute pig's ear, and I think most of the problem was because of the damn zinc pollution. I thought I'd got all the zinc off this nipple, but in fact inside has gone furry as well. Well, I've got this 8-inch piece. I couldn't find a piece of black, that's the trouble. This 8-inch piece, now it's drilled, I'm going to put this in an acid bath overnight, see if I can de-zincify it, and then we'll try and braze that. And I got a new cap and a new short black nipple, so we'll try and make that, but do it again better. Well, a bit of acid pickling and all the gassing had stopped, so I'm pretty much assuming it stripped the zinc off. It should give me a better chance, and I'll prep another cap and short nipple and try again for that. But tomorrow, the temperature's just too darn hot in here right now. Well, I haven't got a filter for the TIG welding, and I'm not over enamoured with my result. I've seen an awful lot better. I got a reasonable fillet round there, but this didn't finish up totally square, but I'm not too worried about it. So put the end cap on, and then we'll wrap this with fabric and screening. I might put some sealant inside as a precaution. There's one little spot on here where I may just have a bit of porosity, I'm not sure. So I'm going to persevere with that and get it put together and see if the damn thing does anything. Oh, the other thing I was going to mention, anybody who remembers the long job I did for the motorised table, I previously only tested it on a 90 amp flux wire, which was alright, but here I have actually set the, let me just check to make sure, I've probably set my foot pedal to about 180, and I was maxing out on that a lot of the time, but the visual inspection underneath of the brush assembly and the brass center, that was all good, and I actually had it set fairly high and was doing incremental advance on the foot pedal, so we'll see where we go. I think I said when I started this it might be a total waste of time. The next thing I wanted to do, actually, I must get round to fitting the chuck to the rotary table. I'll deal with that separately. Alright, this is the progress so far. The inside of the cap, oh, I'm not in frame. The inside of the cap at both ends, I've used up some old body filler actually. Didn't pour very well, but it's just to ensure that I don't get leaks. My braze was not very good, although I'd got everything dezincified. It is possible that my motorized table wasn't quite grounding well enough, but when I gave the foot pedal 100%, I was certainly getting pretty high current and a pretty good bit of heat. Anyway, that's incidental. Look at this. I love the way they put sticky labels on fittings. Most annoying. So anyway, what we've got here, and this isn't quite square to the top, but I'm not worried about it. I've got a bandage, if you like, of screen with this porous cloth in between, and the end cap is on there. I've had air going through it. In fact, I don't know whether, I'm not sure whether I've still got anything turned on. No, I must have turned off. Anyway, the air comes through, but there's no doubt the resistance is such that any really high flow rate probably ain't going to happen. And then this end, the output, again another resistance factor, but I've got to have a fair amount of coverage there to stop the granules escaping, because I want the air to go through the granules instead of putting them in a bag. So I guess we're going to see what happens on here. I'm just trying to get the get the thread started. Oh my gosh. Okay. Looks pretty dangerous, doesn't it? No sir, it is not a pipe bomb. So I think I'll put desiccant in there. Not quite full, probably 3/4 plus, we'll see, and I've yet to test it. But that basically is the end of the project. So I don't think either end brazed all that well. But that easy TIG rod is actually very good most of the time. But I suspect I was probably trying to use a little bit too low a current, or wasn't quite getting the amps through. However, purely experimental. So I'm going to leave it at that, and I'll give a report back on it later if it seems viable. And in the meantime, I'm going to get out of here because it's too damn hot. Ridiculous heat, absolutely ridiculous. And I'll try and get that chuck fitted to the base plate. See which method I'm going to use on that. But again, this is all heat dependent. I stand here and sweat. So and the next thing is it'll be 22 degrees in here and it'll be too damn cold. No mind, that's the end of this little bit of fun and games. Bit boring probably, but anyway, it's just an interesting idea which might go nowhere, probably. Alright, thanks for watching.